Welcome back to 3 Inquisitive Kids. So in this lesson, we will be continuing Chapter 13 with Midlines. Understand the properties and definition of midlines. So as you can see, we already went through parts 1 and 2 of properties of parallelograms, and we also went through all parts of determining parallelograms. So now in this video, we will be focusing on what are midlines and how do we solve problems including midlines with midlines properties. So today our learning goals are to understand the concept and properties of midlines and to be able to use the midline to solve related problems. So first, what are the properties of midlines of triangles? Question 1. Can you split any triangle into 4 smaller triangles of the same area? And question 2 is, connect the midpoints of each 2 sides and see what type of shape you can get. Well, question 2 actually answers question 1, because if you do what question 2 asks you to do, which is take the midpoint of each 2 sides of a triangle, right? So as you can see, each of these 3 points is the midpoint of their respective side, and you connect them, you form a smaller triangle in the middle. And these 3 lines split up this large triangle into 4 smaller triangles with the same area. So knowledge key point. The line segment connecting the midpoints of the 2 sides of a triangle is called a midline. So an example would be if you had points D and E. D is the midpoint on line AB, on side AB, and point E is the midpoint on side AC. A triangle can have a total of 3 midlines, since there are 3 separate midpoints, and if you connect all of them, and if you connect all 3 midpoints on a triangle, and a triangle has 3 sides, you will get 3 separate line segments. If D and E are each the midpoints of sides AB and AC, then DE is triangle ABC's midline. And if DE is the midline of triangle ABC, then this means that points D and E are the midpoints of AB and AC. Draw out all of the midlines of triangle ABC. Draw out all of the medians of the triangle, and then talk about the differences between midlines and medians. So the blue lines in here are medians, and the red lines are midlines. Those are 2 very similar words, and you might confuse them with each other. But here's how I like to remember it. Midlines and midpoints both have MID, mid, as their prefix. So you can connect midlines that are created by connecting midpoints, and medians referring to the lines that split an angle in half. So as you can see, midlines, they split sides in half, and medians split angles in half. Can you assemble a triangle into a parallelogram equal in area by cutting and joining them together? Well, here is my method, Karen's method. Rotate triangle ADE 180 degrees clockwise around point E to the position of triangle CFE as shown in this picture. So we're rotating this yellow piece to the position of the white piece so that a parallelogram DCBF with the same area as triangle ABC is obtained. So let's make a prediction. What is the relationship between midline DE and side BC? And can you prove it? Well, DE is this line segment over here, and BC is this side over here. Their positional relationship is that they are parallel to each other, and their numerical relationship is that DE is exactly half the length of BC. Given that in triangle ABC, DE is the midline of ABC, prove that DE is parallel to BC and that DE is 1/2 of BC. Now you can pause the video and prove this problem. Well, here is our proving solution. We can first extend DE to F, allowing EF to equal DE, connecting CF. Since AE is equal to CE and angle AED is equal to angle CEF, we know that triangles ADE and CFE are congruent. This sign again means congruent, that two triangles are congruent, and we know this through side angle side. AD is equal to CF and angle A is equal to angle ECF. Therefore, CF is parallel to AB. And since AD is equal to BD, we know that BD is equal to CF. So we know that quadrilateral DBCF is a parallelogram. Because DE is parallel to BC, and now let me write out the letter names for these points. This is C, this is F, this is B, this is E, D, and A. Now that DE is equal to 1/2 of DF, which is the same as 1/2 of BC, we know that DE is parallel to BC and DF is parallel to BC. So from this, here is our conclusion. The definition of the midline of a triangle. The midline of a triangle is parallel to the third side and is equal to half of the third side. So this is another important point that you should write down. A midline of a triangle is always parallel to the third side and is equal to half of the third side. Mathematically, we can show this as, since DE is the midline of triangle ABC, we know that DE is parallel to BC and DE is equal to half of BC. From looking at conditions, we will think of the midline theorem of a triangle when we see midpoints, especially two or more midpoints. From the conclusion, it can not only obtain the positional relationship, parallel of the line segments, but also obtain their quantitative relationship, or ships. It is important to combine the two aspects and apply them flexibly when solving problems. So now let's do a few practice problems. As shown in the figure on the left, MN is the midline of triangle ABC. If angle ABC is equal to 61 degrees, then angle AMN is equal to what measure? If MN is equal to 12, then what is the measure of BC? And the second problem is, as shown in the figure on the right, D and E are the midpoints of AB and AC from triangle ABC. When BC is equal to 10 centimeters, then DE is equal to blank. Now you can pause the video and do these two problems on your own. When you unpause, I will be going over both of their solutions. Alright, so let's do the first one. We're given in the problem that angle ABC in the first problem has a measure of 61 degrees. If we know that this is 61 degrees, then AMN must be 61 degrees as well. Why? Because that if a triangle has a midline, that midline is always going to be parallel to the side that it is not intersecting, which means that MN is parallel to BC. And now, using what we've learned previously about parallel lines and their properties, we know that whenever two parallel lines are both intersected by the same straight line, same side interior angles will always be congruent, which means that angle AMN has to be the same as angle ABC. So it will have a measure of 61 degrees. If MN here is 12 units, then BC will have a measure of 24 units. Because according to the second property of midlines, a midline is always exactly half of the third side that it is not intersecting. Now moving on to the second problem. As shown in the figure on the right, D and E are the midpoints of AB and AC from triangle ABC. So D and E are midpoints. When BC is equal to 10 centimeters, then DE is equal to what? Well, again, we know that DE is the midline of triangle ABC. And we know that every single midline is parallel with the third side, the side that it is not intersecting. And we also know that a midline has to be exactly half the length of the third side that it is not intersecting, which means we can do 10 divided by 2, which is 5. So DE is 5 centimeters. Now here is a step-up problem. There are several congruent triangles in the figure. Can you prove that this statement is true? And how many parallelograms are in the figure? Can you prove it? Here, the several congruent triangles would be AEF, EFD, EBD, and CFD. Why? Because all midlines of a triangle have the same length. Go on and try to see if you can prove this statement. And leave your proving process and your logical reasoning in the comments down below. And that's where you guys can share different solutions you guys had for this problem. And 2 is how many parallelograms are here in the figure? Well, all we have to do is count. There is a total of 3 since we have AEDF, EBCF, and FCDE. Now the first part to our third problem. Given that the lengths of the triangle are each 6 centimeters, 8 centimeters, and 12 centimeters, then connecting the midpoints of each side to form a triangle would have a perimeter of blank centimeters. Now this problem is the best to draw something out. So you can first draw the model of this triangle out, and then connect their midpoints, and then you can find the perimeter of this smaller triangle. The answer would be 13 centimeters, and let me draw this out for you. So we have a triangle with a side length of 6, 8, and then 12. We connect the midpoints of each side, and then we connect. Now, let's use a property of midlines in order to help us solve this problem. Which property discussed the lengths of midlines? Among property 2, it said that each midline is half of the length of the third side that it is not intersecting. So for example, let's look at the top midline here. That goes from the 12 centimeter length side to the 6 centimeter length side. So this line right here, this line segment, we know that it is parallel to the bottom side of the triangle, and that it is half of the bottom side. So the half of 8 would be 4. Now we do this for all the other midlines. For example, this midline over here, it has to be half of its opposite side, which is 12. So 12 divided by 2 is 6. And this midline right here has to be half of the side that it is facing, which is 6. So half of 6 is 3. And now that if you add them all together, you have 13 centimeters. And here's the second part. Given that the perimeter of a triangle is 64 centimeters, therefore connecting the midpoints of each side to form a triangle will have a perimeter of blank centimeters. This will give us 32. Now, how were we able to solve this problem? Well, let's first use variables to help us prove. Let's assume that the lengths for each of the 3 sides of this triangle is respectively A centimeters, B centimeters, and C centimeters. So these are its variables. Now we know that the smaller triangle formed inside of this original triangle out of its midlines would have lengths that are exactly 1/2 of each of these, A, B, and C. So let's first write our equation. A plus B plus C, the sides of the original triangle, is 64 centimeters. Now, if we had a side that was 1/2 of A, right, one of the sides of this smaller midline triangle, plus 1/2 of C. Added together, we will have a sum that is 1/2 of the original sum, 64, which would be 32. So in the end, we will have 32 centimeters as our answer. Now here is the third part. What is the perimeter of triangle ABC is A. D, E, and F are each the midlines, are each the three midpoints of the sides of triangle ABC. The perimeter of triangle DEF would be blank. Well, if we know that the perimeter of triangle ABC is already A, then we know that the perimeter of DEF would be 1/2 of A. The same thing we used for the previous problem. G, H, and I are each the midlines of the sides of triangle DEF. What would be the perimeter of GHI? Well then, that would be 1/2 of 1/2 of A, which would be 1/4 of A. So from this, what have you concluded? Continuing this pattern, the third triangle continuing this pattern will have a perimeter of 1/8 of A. So you continue multiplying 1/2 to the previous term you have in this series. And the nth triangle will have a perimeter of 1/2 raised to the nth power, A. What other thoughts do you have about this? Now here is number 4. As shown, D, E, and F are each the midpoints of the three sides of triangle ABC. What is the relationship between the areas of triangle DEF and ABC, and why? So here is our solution. DF and EF are the midlines of triangle ABC. So DE is parallel to BC, and DF is parallel to AC, and EF is parallel to AB. Quadrilaterals ADFE, BDEF, and DECF are all parallelograms. So the areas of all four of these triangles are the same. Since all four of these triangles have the same area, we know that triangle DEF will be 1/4 of the area of ABC. Let me write that in, 1/4. As shown in triangle ABC, AB is equal to 3 centimeters and BC is equal to 3.4 centimeters, and AC is equal to 4 centimeters. DE and F are each the midpoints of AB, BC, and AC. Then the perimeter of triangle DEF is blank centimeters. That would be 5.2. Here, all you had to do to solve the problem was take the perimeter of the original triangle and then divide that by 2. As shown in right triangle ABC, angle A is a right angle. DE and F are the midpoints of each side. AB is equal to 6 centimeters and AC is equal to 8 centimeters. So what is the perimeter of triangle DEF? There is a second step to this. So let's first label what we know. AB has a measure of 6 centimeters and AC has a measure of 8 centimeters. And we're trying to find the perimeter of the smaller triangle made up of the medians. But the first thing we have to do is find the length of BC. That's really the unknown here. What is BC? Because after we know BC, we can find the perimeter of the original triangle, and then from that we can divide by 2 and get our answer. The problem here is that we are not given the length of BC. But how can we find the length of BC using what we already know? The lengths of AB, AC, and that angle A is a right angle. Well, what immediately comes to your brain when you think of right angles? Of course, in geometry, that would be the Pythagorean theorem, because it's a triangular theorem that applies only to right triangles. So the Pythagorean theorem says a squared plus b squared is equal to c squared. Here our a is 6, so 6 squared is 36, plus b squared, which in this case is 8. 8 squared is 64, is equal to c squared. Now 36 plus 64 is 100. So 100, and that takes the square root of 100, and we have 10. So the length of BC would be 10 centimeters. Now, this isn't the only way we could have solved it. If you're somebody who's really, really skilled with the Pythagorean theorem, you should know that there are two very common sets of numbers that come up when dealing with the Pythagorean theorem. One is 5, 12, and 13, and one is 3, 4, and 5. These are perfect Pythagorean theorem number sets because they fit into the Pythagorean theorem without any decimals or fractions coming up. So in this case, we are actually using this set of numbers right here because 6 is just 3 times 2, 8 is just 4 times 2, and 10 is 5 times 2. So we can just add to find the perimeter of triangle ABC, divide by 2, and we have 12. Class summary. Midlines of triangles. Today we learned about its definition. The line segment connecting the midpoints of the two sides of a triangle is called the midline of a triangle. Remember, midlines and medians are two very different things. Midlines, you can remember it as the line segment that connects two midpoints of a triangle. Midlines and midpoints sound very similar, so that's where you can differentiate them. Now, properties. The midline of the triangle is parallel to the third side and equal to half of the third side. And by third side, I just mean that the side that it is not intersecting. Again, to review. Today, the two skills we worked on is to understand the concept and properties of midlines, and the ability to use the midline to solve related problems. Now that wraps up our lesson for today. If you enjoyed this video or learned something new, please hit the like button. And if you would like to see more Inquisitive Kids content like this or follow along to the end of our chapter 13, be sure to be notified when we upload new videos. So be sure to click that subscribe button and the notification bell. Thank you so much for watching through Inquisitive Kids, and we hope you have a good day.